Having a look here at your three-phase induction motor, which is used in many applications in industry and drives varying loads. But here just to look at what's inside the motor when you look at them, it's just a lot of Lecos, all they do is just connect up the three phases, turn it on and away it goes. So how the motor actually works is I've got this little demonstration panel over here, a little cutaway version of what's inside a three-phase and electric motor. So I've just got an old coffee can here as simulating the rotor of the motor, but the windings in the stator, you can see we've got red, white and blue, red, white, blue going round three-phase. So inside there's basically three identical windings for each phase, and they can be connected in star or delta. So as you can see there, so there's three identical windings with a start and a finish, start, finish, start, finish. And they can have a star point where all the finishes are joined together and a three-phase supply coming in on your three-terminal, three-wire motor. Or delta, where we join the finish of one winding to the start of the next, finish to start, start to finish, and finish round to start. So start to finish, start to finish, start to finish, to give you that delta connection, which gives you slightly higher torque from the same motor. So it can be connected either way depending on application. But what's inside there are these three identical windings, as I say, and they set up what's called a rotating magnetic field in that stator, and the yoke of the motor here has got that iron circuit around there which creates this rotating magnetic field that occurs in there. That magnetic field induces a voltage into this closed circuit, which is the rotor. So they're typically a squirrel cage rotor in the three-phase machine, and for the induction motor, and they're just made up of skewed bars inside there with short-circuiting rings on the end of the squirrel cage, and it's really similar to just a closed circuit of this one, an old coffee tin just inside there. And you can see there's no electrical connection inside between the rotor that spins with inside the magnetic field. So the magnetic field rotates in the stator, and that moving magnetic field induces a voltage, thus induction. So electromagnetic induction occurs into a closed circuit that's basically like a big short circuit inside there. So if you've got a voltage, you've got a high current that starts to flow inside that rotor. That current that's flowing inside the rotor sets up its own magnetic field, which reacts with the rotating magnetic field, and you've got this force of motor action that's pushing and spinning the rotor in the direction of the RMF, the rotating magnetic field. So you can see that just by demonstration. Turn the three-phase supply on, and you can see how the compass shows the direction of the magnetic field as I spin around. You can see that moving. If I turn it off, there's no magnetic field within those stator windings. So as I say, that's just very simply and basically how a three-phase induction motor operates.